Good day, everyone. This is a chemistry JAMB past question. So I tried to solve it with you guys. So let us go. This question says elements P, Q, R, S have 6, 11, 15, and 17 electrons respectively. Therefore, you can see the options. So before you can solve this question, you need to have a good knowledge of chemical bonding. So actually, this is it. We have different types of chemical bonding. We have the ionic or electrovalent bond. Ionic or electrovalent bond. We have the covalent bond. We have the coordinate covalent bond. We have hydrogen bond. Hydrogen bonding. We have metallic bonding. And many more. We also have our forces and the rest. So in this video, I'll be explaining ionic bonding and covalent bonding, because that is all we need to solve this particular question. So let us delve in. Let me start with ionic bonding. Ionic bonding. Ionic bonding. So ionic bonding is a type of a bonding whereby an atom completely transfers electrons or an electron to another atom so as for it to get stability. I hope you are following me. So for it to get stability, that is one function or mainly the function of chemical bonding. So let me explain. An example of a compound that exhibits ionic bonding is sodium chloride. Sodium chloride. So let me explain why sodium chloride exhibits ionic bonding. You know, sodium has an atomic number of 6, let me hear. That's correct. Has an atomic number of 11. That means that it has 11 electrons. So let me explain this in the simplest way for you to understand. So chlorine has an atomic number of what? Let me hear. That's correct. 17. 17. That means it has 17 electrons. So let us try to draw the structure. Let me say the diagrammatic structure of this electronic configuration. Hope you are following me. So let us do it like this. Let me say the first shell has 2 electrons for sodium. The second shell has 8 electrons. Okay. I hope you are following me. Has 8 electrons, and the third shell we only have 1 electron to make it a total of 11 electrons. This is 2 plus 8, that's 10 plus 1, make it 11. While for chlorine, the first shell we have 2 electrons normally. The second shell we have 1, 2, 3, 4, 5, 6, 7, 8. Don't worry, I'll explain why the second shell actually has 8 electrons in my subsequent videos. So the next shell will have, this is already making 10. So the next shell will have 7 electrons. Let me see, 1, 2, 3, 4, 5, 6, 7. You can see. So this actually has 1 electron on its valence shell. Sodium has 1 electron. 1 electron on the valence shell. Or let me say it has 1 valence electron for sodium. You can see chlorine has 7 valence electron. Valence electron. Chlorine has 7 valence electron. You know, for these compounds to actually gain stability, for these 2 different atoms to bond together, there need to be actually stability. Chlorine needs one more electron to complete the octet structure for it to make 8. Why? Sodium needs to lose one electron for it to gain stability so it can form octets too. So now sodium will completely transfer this electron to chlorine. It will completely transfer this electron to chlorine, whereby it will transfer this one electron to chlorine. So sodium will now become like this. You can see. So if you have 10 electrons, making it to be N plus, making it to be charged, that means it has lost one electron. So now for chlorine, after sodium has transferred one electron to chlorine, on the valence shell, we have here with 1, 1, here we 1, 2, 1, 2, 1, 2, 1, 2, making 8, and here it will also have 8 because sodium has transferred one of its electrons, which is this, to chlorine. So chlorine will be having 18, it will be having 18 electrons now, which will make it Cl minus. So this is actually how sodium chloride was formed. This is how sodium chloride is formed from ionic bonding. How do you get this now? Ionic bonding is formed when an atom completely transfers its electron to another atom so it can become stable. Now about covalent bonding. So covalent bonding is a type of a bonding whereby electrons are shared between the participating atoms. So I want you to focus on this. I'll be giving you 2 quick examples. Follow me on this one. So let us use a compound which is hydrochloric acid, which is HCl. First, I'll be using oxygen gas. But let us deal with HCl first. We all know that HCl has an atomic number of what? Hydrogen has an atomic number of what? 1. And chlorine has an atomic number of what? 17. That's correct. So now let us just draw the diagrammatic electronic configuration of oxygen. It only has 1 electron. You see? For chlorine, it has this. I think this is the best way I can explain this because this is very, very simple for anybody to understand. Okay, and the last shell, it has 7. Let me put 1 here, 2, let me put 2, let me put 2 here. So it is complete. So now for this hydrogen to achieve stability, or for chlorine to get to stability, they must share the electrons they have. Hydrogen needs 1 electron to complete stability. While chlorine also needs 1 electron. So in this case, there needs to be a mutual relationship. They need to help each other to attain stability. So something like this will now occur. This is for hydrogen and this is for chlorine. Okay? So let me try to put this and this one. Okay, you can see. So here it also has this, and that's just 1 here. So now, also, hydrogen also has 1 electron. So hydrogen will also donate 1 electron. So you can see now, the hydrogen is now making 2. Hydrogen is having 2. That means it is stable. Also, chlorine is now having 8 on its valence shell. So it's also stable. So this is covalent bonding. It forms hydrochloric acid. You can see. So it can happen for any compound. And go back to the question. Elements P, Q, R, and S having 6, 11, 15, and 17 electrons respectively. Therefore, option A, P will form an electrovalent bond with R. So I've written something here. P, Q, R, S. 6, 11, 15, and 17 electrons. So that we won't get confused. P has 6 electrons, Q 11, R 15, S 17. So now let us see if option A is correct. They said P will form an electrovalent bond with R. P having 6 electrons. So let us draw the diagrammatic electronic configuration. So this. You can see this makes 6 electrons in total. This is for P. While for Q, let us draw everything at once. For Q, they said Q has 11. Okay. This will be 10 shells because we need 1 valence electron. Okay. For R, let us draw for R. R has 15. Okay. So 1, 2, 1, 2, 1, 2, 1, 2, 1, 2. This is 10, so it will be remaining 5. 1, 2, 3, 4, plus 5. So for S has 17. Okay. So that will be like this. Okay. I'm drawing this diagram so that you can find it really easy to understand. There is a very simple way I can do this, but I want every single person to understand this. So this is P, Q, R, and S. So now let us check the option A. P will form an electrovalent bond with R. P will form an electrovalent bond with R. And according to what I said before, I said an electrovalent bond is a type of a bond. We call it electrovalent or ionic bonding. So it's a type of bonding whereby an atom completely transfers an electron to another atom. So in this case, let us say even if Q transfers one electron to this one to be stable, this one will only have 5 valence electrons and it is not yet octet, it is not yet 8. So this option is cancelled because it is not true. It can never happen for these two atoms to combine or to bond in that kind of a way. So let us go to the next option. Option B. Q will form a covalent bond with S. Q will form a covalent bond with S. So Q will form a covalent bond with S. So according to what I said before, I said a covalent bonding is a type of bonding whereby electrons are shared between the participating atoms. Okay, so in this case, if there's going to be any type of a sharing, if this is going to share with this and this is going to share with this, it is not going to be possible because if this actually shares all of these 7 electrons with this, it will not be possible. So it will not work in that way. Let us check the option C. R will form an electrovalent bond with S. R will form an electrovalent bond with S. Okay. I know you guys electrovalent bond is a type of bonding where electron is completely transferred. So let us check this. If this one wants to completely transfer electron to this is not going to be stable. You get, this needs to attain octets. So this needs one, if it shares one, it should not be stable. So this is completely out. So for this one, the last one, Q will form an electrovalent bond with S. Q will form an electrovalent bond with X. I think this is going to work because Q can transfer just 1 electron to S, and then Q will have a structure. We have this type of structure. Okay, we have this type of structure because it will lose 1 and it will become octet structure. So it's already balanced. This is already stable. And also S, we have this type of a structure. After getting 1 electron from Q, it will have this type of a structure. So Q will completely transfer 1 electron to S, and that is an electrovalent or ionic bonding. That's an electrovalent or ionic bonding. So this option is correct. I believe this is very, very clear to you. If you don't understand anything in this topic, kindly drop it in the comments. See you guys